question.
How does a potato battery work?
Your great Aunt Gladys.
Hello, Great Aunt Gladys. How are you? I hope you're feeling fine. I'm Joshua, as you know, your favorite grandnephew, and these are my friends from school, Daniel and Long Yu.
Hi.
And they're here today to help me explain how a potato clock works. Now, regarding your question about potato clocks, they actually aren't that different from a normal clock like the one hanging on your living room wall. But of course, to understand how potato clocks work, you'll have to understand how a normal clock works first.
This is a clock, and so is this, and this. Clocks come in a variety of shapes and sizes, and although even the simplest pocket watch can have dozens of parts, there are only three main components crucial to the functioning of any clock. The first component is the motor. This is anything which drives the inner workings of a clock. Most modern clocks use DC motors, while older clocks, like the ones you might find in your house, can use metal springs to drive the gears. Next is the gear mechanism. This transforms the rotation of the motor into precise movements of the hands, so that the clock always displays the right time. In newer clocks, a microcomputer chip can replace the gears, while in your antique clocks, you may see pendulums being used instead. The third main component is the power source. This is what drives the motor. It can be the AC mains of your house, or dry cells for modern wall clocks and watches, or even you when you're winding the mainsprings of your clocks in the morning. A potato clock only differs from any other clock with its power source, which is a potato battery instead of a dry cell. Now, before we get into how a potato battery works, let's get a quick overview of atomic theory.
As you might know, everything can be broken down to little pieces called atoms, and atoms are made up of many parts. They're surrounded by electrons, which have a negative charge, and inside they have protons and neutrons, with protons holding a positive charge. When you remove some of these electrons or add some of these electrons, you give these atoms charges, and these atoms are now called ions. Like a normal battery, potatoes have an electrolyte solution in them. An electrolyte solution is basically ions floating around in water that allows electricity to pass through. In a potato, the electrolyte solution is phosphoric acid, diluted with water. We can't just use a potato as a battery. We have to add more components into it to make it become an actual battery. In order to do that, we add a zinc strip and a copper strip to emulate the negative ends and the positive end of a battery. By adding the zinc strip, we make an anode, or negative end, and by adding the copper strip, we make the positive end, or the cathode. Finally, for the potato battery to actually act like a battery, it has to send electrons from the anode to the cathode. So, you might be wondering where the electrons came from. Well, remember when we inserted the zinc earlier? That zinc releases two electrons, forming the positive ion Zn2+. Those two electrons then moved on down the wire, and that is what passes electricity in the circuit, which powers the potato battery. The two electrons react with two lone protons, also known as hydronium ions, to form hydrogen gas. Finally, we connect the wire to the clock, and bam, there you go, potato clock. To better help you understand how a potato clock works, we made a model to demonstrate. Our battery consists of 3 potato electric cells with a series circuit, along with strips of zinc, the anode, and copper, the cathode. Our battery can power an LED light, one segment of a 7-segment display, and of course, my alarm clock from my room.
In conclusion, a potato clock has the exact same basic components as a normal clock, consisting of a power source, a motor, and a gear train. However, the only difference is that in a potato clock, the power source is a potato battery instead of a normal one.
The potato battery emulates a normal battery by sending electrons from the anode to the cathode. And finally, the reaction between zinc and phosphoric acid provides the electrons, which powers a potato battery clock.
Wait!
Damn! Those bananas.
It gets shortened.
A gear mechanism which changes the power into...
We have a really ghetto tripod, but... Damn it, okay.